We have discussed the phenomena of scattering of light by colloidal particles, and this is known as Tyndall effect. In the nature, we know that the particles which can scatter the light or the scattering particles can be of varying size, and the color of scattered light depend on the size of scattering particle, because the different color light will have different wavelength. Smaller particles scatter light of small wavelength, mainly blue. And the particle of larger size can scatter light of larger wavelength. This we can understand simply with if light is passing through a medium where the particle size is very small, and we see another one where the size of particle is little bigger. So what will happen if we try to understand the concept of color of scattered light with the analogy of size of the stone and the insects passing through? For example, for a small ant moving in a straight line, the small sand particle is big enough to obstruct its path and make it change its path in a way, kind of reflection taking place in the case of photon and the particle. To understand the relationship between the wavelength and the color of scattered light, we will take a simple analogy where the medium with some small particles are there. So if we take a blue light which is of smaller wavelength passing through this medium, so all these small particles are big enough to make that alter its path or get scattered, something like this, and all these particles will add on to the process of scattering, and we will find that the light of smaller wavelength scatters significantly in that medium. But when light ray of larger wavelength travels through, we can imagine that it is passing pretty unaffected through this medium, not getting scattered. But when it comes in contact with the bigger particle, it will get affected the same way as the light rays. The blue light ray is getting affected by the small particle. So that's why the size of the scattering particle is affecting the color of the scattered light.